In this video, I am going to explain the charging concept of the capacitor. In this video, I am going to explain the charging concept of the capacitor. Before deriving the capacitor charging voltage expression, all of you must know the fundamentals of the capacitor. This is the two parallel plates. These are the two parallel plates. These two parallel plates, charge distribution of like metal parallel plates. Charge distribution is like this here, plus minus plus minus, separated by a distance is equal to separated by distance small d. Capacitance of that parallel plate capacitor is C is the capacitance of this parallel plate capacitor. Here some dielectric is there in between these two metal plates. Some dielectric is present. Find out the capacitance of the capacitor. That formula is C is equal to epsilon naught into epsilon R into A by T, where epsilon naught is the free space relative permittivity, free space permittivity, free space permittivity. Epsilon R is the relative permittivity. A is the area of the metal plate. Area of the metal plate. This is the two metal plates. The charge distribution is like that, plus minus equally distributed. That means these plates are neutral. The capacitance of that capacitor is parallel plate capacitor is C is equal to epsilon naught into epsilon R A by D, where epsilon naught is the free space permittivity, epsilon R relative permittivity of the media, A is the area of the plate, D is the distance between the plates. D is the distance between the plates. Suppose a DC voltage is applied to the plates. See the one pair plate 1, metal plate 1, and this one is metal plate 2. The charge distribution is plus minus. Positive charge and negative charges are equally distributed. Suppose these plates are some resistance is connected in series. Here some switch is used here. This is the switch. some DC voltage V volts is applied to this parallel plate capacitors. The capacitance of that capacitor is C. The voltage across this parallel plate capacitor is C. Here, initially, according to time analysis, T is equal to 0, T minus, T plus, T is equal to infinity. At T is equal to 0 means the switch is suddenly closed. At T equal to plus means as time increases and the performance of that capacitor also changes as time increases. At T is equal to infinity means steady state has been reached. T before the instant T minus, that is T minus. The T minus instant, the switch is open. Here, this is the circuit belongs to T minus. T minus. Now at T is equal to 0, the switch is closed. At T is equal to 0, the switch is closed. Initially, there is no voltage across this capacitor. Before that at T minus, before closing the switch, Vc is equal to 0. At T is equal to 0, the switch is suddenly closes. At that instant also Vc is equal to 0. Vc is equal to 0. The voltage across the capacitor is equal to 0. As the T value changes, that T value increases like that, and the capacitor is charged. At T is equal to 0, this one, the behavior of the capacitor is like that. Plus, minus, plus, minus. Here this is the plus, minus, plus, minus. This is the resistance. Capacitor value is C. The switch is suddenly closed and V volts applied to this capacitor. This is the positive, this one is negative. The voltage across the capacitor is Vc. At T is equal to 0, T axis, this one is T is equal to 0, this is the Vc. Vc is also 0. Here, this is the positive terminal of the battery, attracts the electrons. Here, 2 electrons are there here. These are the 2 electrons. These 2 electrons are attracted by this positive terminal of the battery. And this is the dielectric. This one is the dielectric. These 2 negative charged particles are reached to this place, this plate. This negative particle, charged particle and the positive charged particles are combined. Therefore, these 2 are appeared. This positive charged particle of this plate, second plate, and the negative charged particle is coming from the first plate. These 2 are merged at the second plate, therefore disappear. Electron hole pair is disappear. At T is equal to 0. The important points here is the capacitor acts as a short circuit. At T is equal to 0, the capacitor the capacitor acts as short circuit. Why this capacitor acts as short circuit? Suddenly the switch closes. The capacitor and fundamental property is it opposes the sudden changes in voltages. Therefore, at that instant, at t is equal to before t is equal to 0 means t minus Vc is equal to 0. At t is equal to 0, suddenly the switch closes. But important property of the capacitor is opposes the sudden changes in voltages. Therefore, again at t is equal to 0, Vc is equal to 0. That means the capacitor acts as short circuit. This is very important point. As time goes on increases, at any instant of time, any instant of time. That means as time goes on increases, at a particular time, this plate becomes positively charged plate, and this plate becomes negatively charged plate. Some resistance is also there here. This is the short circuit. The switch is closed. Closed. Here V volt is equal to 0. Here V volt is V equal to 0. The capacitance of the capacitor C. Here this one is the Vc is equal to V. EC is equal to V. The voltage across the capacitor Vc is equal to V means these two plates are changes. Here this plate is converted into a positively charged one. This plate is converted into negatively charged one. Some electric field direction is created from positive to negative at a particular instant, at an instant of time. That means the capacitor is fully charged. The capacitor is fully charged to applied voltage as time goes on increases. Initially, the capacitor acts as a short circuit. At t is equal to 0, the switch is closed. Capacitor opposes the sudden changes in voltage because before the switch is closing, the capacitor voltage is equal to 0. After suddenly closes the switch, the capacitor voltage, initial voltage is also 0. Here, this is the Vc. This is the time axis. At t is equal to 0, the capacitor voltage is equal to 0. Based on the time constant tau, product of R into C is the time constant. This is the 1 time constant, 2 time constant, 3 time constant, like that. As a t value increases means the time based on the time constant, the capacitor is charged like that, and finally reach it to supplied voltage V. T is equal to here t is equal to 0. Here t minus. Here t goes on increases. At t is equal to infinity, steady state has been reached. Steady state means V volts. The capacitor is fully charged to V volts. These are the some fundamental points related to capacitor. These points are play an important role for derivation. Capacitor charging equation derivation. That is very important. These are the fundamental points. Now I will concentration on derivation. Capacitor charging derivation, that is represented by base. It is a function of our time. That is Vc of t. Consider this circuit. This is V volts. Here a switch is there. A resistance R and capacitor is C. Capacitor is C. This is the switch, V volts. Here the charge on the capacitor Q. Here the charge on that voltage is equal to voltage source is Q. Here Q is equal to CV. Here Q is equal to here VC is the capacitor voltage. VC into C. Suddenly the switch is closes. At that instant of time, this capacitor initial condition, the capacitor acts as a short circuit. At T is equal to 0, the switch is closed. The switch is closed. Therefore, the capacitor acts as short circuit. Okay. The switch is S is closed. This is the S. This is the resistance. The capacitor acts because initially the capacitor is uncharged. At T is equal to 0, VC is equal to 0, charge on the capacitor Q is also 0. Therefore, that means acts as short circuit. Here the voltage source generates some current that is called that current is maximum IM, maximum current. Therefore, this is the maximum current. IM is equal to the voltage across this one is VR. Apply KVL minus V plus IM into R is equal to 0. Apply KVL to the loop. Here apply KVL to the above loop. Minus V plus R into IM. Plus R into IM. Therefore, minus V is equal to minus IM into R. From this expression, the capacitor charging current, initially the charging current is maximum. M represents maximum current because V is equal to VR. At T is equal to 0, the switch is suddenly closes. The capacitor acts as a short circuit because the initial voltage across the capacitor VC is equal to 0. Charge on the capacitor Q is also 0. That means that condition is called at switching instant. This is called as at a switching instant. At a switching instant. Okay. The current is maximum. The current is charging current is maximum. This is the fundamental point. At any instant of time. Second one is at any instant of time. Because T increases. Okay. The capacitor starts to charging. It acts as a so it develops some voltage across the capacitor that is represented by VC. Therefore, the circuit diagram is V. The switch is closed. The switch is closed. Here resistance R. Here capacitor C. The charge on the capacitor is Q. Here capital Q. Voltage across the capacitor is VC. Because VC is also there, the current is I. Here plus minus. Here plus minus like that. Apply KVL. Apply Kirchhoff voltage law to the above loop. Here minus V plus R into I plus Vc is equal to 0. Vc means voltage across the capacitor. C is the capacitance of the capacitor. Here V is equal to Ri plus Vc. We know that I is equal to C into dV by dt, but V is called as Vc by dVc by dt. Substitute this I value in the above equation. V is equal to R into C dVc by dt plus Vc. Rearrange this above equation. Rc dVc by dt V minus Vc. V minus Vc. Here dVc by here V minus Vc dt by Rc. dt by Rc. Integrating on the both sides of the above equation. Integrating the above equation on both sides. Integral of dVc by V minus Vc. Integral of dt by Rc. Here important point here is dVc. Here V minus Vc with respect to integration is dVc. Here 1 by Rc with respect to dt. Here according to let V minus Vc is equal to x. dV differentiation on both sides like that. dV minus dVc is equal to dVx. This is the voltage is constant. This value is 0 minus dVc is equal to dx. From this equation dVc is equal to dx, substitute dVc is equal to minus dx. Here V minus Vc is equal to x. That is equal to dt by Rc. dt by Rc. Here minus integral dx by x is equal to 1 by dt by Rc. 1 by x integral of 1 by x dx is log x base e. This integration is one by Rc is constant. Integral of 1 dt is equal to t plus some constant k. Here x is equal to, we know that x is equal to V minus Vc. Here minus log V minus Vc t by Rc plus k. This k value is determined from the initial conditions. Initial conditions means at t is equal to 0. At t is equal to 0, Vc is equal to 0. There is no charging voltage across the capacitor. We know that. At t is equal to 0, Vc is equal to 0. Substitute these initial conditions. These are the initial conditions. Initial conditions. Substitute these initial conditions in this equation. Therefore, log Vc is equal to 0. V base E. T is equal to 0 means 0 by Rc plus K. Therefore, K is equal to log V base E. Substitute this K value in this equation. This K value here, that is equal to minus log V minus Vc base C T by Rc. K is equal to log V base C. This log V basic changes to this side, minus log V minus Vc base C plus log V base C is equal to T by Rc. This is the log A base C minus log B base C formula is log A by B base C. Here log A base C minus log B base C means log A by B means V by V minus Vc base C is equal to T by Rc. Log x e is equal to y is equal to e power y is equal to x. This is the another formula. Here x is equal to v by v minus c, y is equal to t by rc. That means e power t by rc x is equal to v by v minus c. Changes this sign here. E power minus t by rc is equal to v minus c by v minus vc, not c, v minus vc. V minus Vc by V. Therefore, this is the V minus Vc is equal to V into e power minus t by Rc. Find out Vc, capacitor voltage. Vc is replaced in this side. V into e power minus t by Rc transformed in this side. V minus V into e power minus t by Rc is equal to Vc. Therefore, the charging voltage across the capacitor is Vc is equal to V into V minus V into e power minus t by Rc. Therefore, Vc is equal to V into 1 minus e power minus t by Rc. Here is a function of time, that is equal to Vc of t is equal to V into 1 minus e power minus t by Rc. This is the charging voltage across the capacitor. This is the charging voltage across the capacitor. Across the capacitor is a function of time. Is a function of time. Suppose we know that Vc is equal to 0 at t is equal to 0. Prove this condition by using this expression. T is equal to 0. Substitute t is equal to 0. V into 1 minus e power minus 0. That is equal to V into 1 minus 1 by e power 0 means 1. 1 minus 1, that is equal to 0. At t is equal to 0, the switch is suddenly closes. Capacitor opposes the sudden changes in voltages. Therefore, the voltage across the capacitor is 0. At t is equal to infinity, At t is equal to infinity means steady state condition has been reached. Steady state condition has been reached. That means substitute t is equal to infinity. Vc of infinity is equal to v into 1 minus e power infinity. E power infinity by RC, that means infinity. E power infinity is 0. That is equal to V. The capacitor is charged to applied DC voltage V at okay. Find out graphical representation. Representation. This is the time versus Vc of t. That means V into 1 minus e power minus t by RC. Here t is equal to 0. Time constant tau is equal to RC. Tau, 1 tau, 2 tau, 3 tau, 4 tau, like that. T value is like that. Substitute T value. T value is different. T value is equal to 0. T value is equal to tau. T value is equal to 2 tau. T value is equal to 3 tau, and so on. The capacitor value is Vc of t is equal to V into 1 minus e power. T is equal to tau means RC by RC. That is equal to V into 1 minus e power minus 1. Calculate this value by using calculator. Here Vc of t, V into 1 minus e power, t is equal to 2 tau. Tau means RC. That V is equal to 1 minus e power minus 2. 3 tau. Vc of t is equal to V into 1 minus e power minus 3RC by RC. That is equal to V into 1 minus e power minus 3. Like that, we have to calculate this Vc of t. Initially at t is equal to 0, Vc of t is equal to 0. That value, steady state condition means, that means V volts. The capacitor charging is like that. Initially the voltage across the capacitor is 0. As the time goes on increases, based on that time constant RC, the capacitor is charging is like this. With this, the voltage across the capacitor derivation is completed. At any instant of time, the voltage is equal to VC of t is equal to supplied voltage V into 1 minus e power minus t by RC, where RC is called as RC is equal to tau, is the time constant of the circuit. With this, the derivation is completed. In the next video, I will derive the discharging concept of that discharging equation of that capacitor. Okay, if you like this video, please subscribe the channel for further updates. Thank you.